Just like the street lights lit this town, like a fire in a blaze, gotta burn it down. Can't be afraid to leave this out. We got this far, don't know how. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we're gonna let it away. Tonight, we're gonna let it away. Tonight, we're gonna let it away. Just like the sunrise, we're gonna let it away. Just like a spark that's breaking out. Can't make a stop, can't turn back now. We know that there's no room for doubt. No, we can't turn back now. I see danger in your eyes. They know we'll burn down the night. Coming just like the sunrise. You know that we're gonna let it away. Tonight, we're gonna let it away. Tonight, we're gonna let it away. Just like the sunrise, we're gonna let it away.
Over the edge, feel like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to kick the habit that my mind is breathing in. Break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless. Burning the bridge that keeps us. I'm here and I'm feeling fearless. Exaggerated, that's what you assume. The story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance. Not the life I want to live, I want to take it all. Standing tall, fear I weighed the person you are. Oh, break out, I've got inside. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And we'll grow in number, fueled by them to see the horizon, turn us to thousands. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. I don't know what you want. Let's have a bit of fun till I downfall. My love, if you feel like I do right now, don't say you're on the run to the other side, my love.
have a bit of fun till I downfall. My love, if you feel like I do right now, don't say you're on the run to the other side. My love, you say you wanna try, but you never do. Sugar, there's a reason why we lose.
I live inside my own world of make-believe. Kids screaming in their cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Take my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Content, hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption. Breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out. Be carefree lately, yeah. Just picking up daisies. Got one too many quarters in my pockets. Count 'em like the 4-leaf clovers in my locket. Untied laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep.
Alright, with that end of the song, I thought I'd let the song finish first. Gotta let the song finish first, right? With that, I'm gonna start the stream. I am aware that there is nobody here in the stream right now, but you know, stream's gonna be recorded and put online anyways. Hi. Welcome to this very unprofessional stream. I am not doing anything special with it. This is legit more of a devlog rather than a tutorial series or anything like that. I want to kind of show off like what it takes to make a programming language and also show my learning process behind it. So I thought I'd just stream everything that I do, and then if I ever, you know, make mistakes or whatever, I can go back to it. But you can actually see like because a lot of videos on YouTube are just people, this is how you make this is how you do this. It's not a lot of like just the actual process behind making something new. You don't really get to see it, so I thought I'd kind of show that off a little bit. What we're going to be making here is a programming language, as you can tell by the title. We're going to be making a compiler. So essentially, I'm just going to get right into the video. Essentially, a programming language works as you have this text document, right? And this text document contains all of your code, right? This has all of the code inside of it. This code actually means nothing. It is just text. This is just text. It's the same thing as like a .txt file, right? It's just text. A compiler, on the other hand, is a program that takes that text, runs it through a set of stuff. It's just an executable, right? It's just a program. Just a program. And it outputs some sort of binary code. It outputs another program, right? And so essentially what it's doing is it's reading all of the text inside of here, figuring out what it's supposed to do, and then translating it. It is a translator. Think of like Google Translate, right? I can write something in Spanish, but that doesn't mean anything to my friend over here who only speaks French, right? It legit just translates from one thing to another. That way your computer can understand and run the code here. There are many different ways of doing that. A compiler obviously creates an executable file, but you could also do a transpiler, which just translates it from text to another programming language. You could also do like a interpreter, which is things like JavaScript, Python. All that stuff is an interpreter, and it reads your code line by line, right? So you have your different code, right? So you would have like int, ignore my terrible handwriting, but like int x is equal to 2, x equals x plus 1, return x, right? And what it does is it turns all of this into an intermediate code, or IR for short, intermediate representation, and it reads all of this line by line and executes the code inside of the program itself. There's no output code, there's no separate executable, it's all running inside of the program. It's just reading it and running it in a safe environment so you don't corrupt anything. But doing it that way does make it a lot slower and use a lot more memory because it's trying to figure all of that out on the spot rather than ahead of time, which is why I'm trying to go for the compiler here. Now, another reason I'm going for the compiler is I want this to, and I don't know why this isn't, how do I erase on here? There. So another reason that I'm using a compiler is I want to use a form of IR, right? This is going to be, so IR, again, just means intermediate representation, and it's bytecode. It's not code that the computer understands, but code that a program understands and can run. However, this IR, instead of just running a normal program, essentially, you're going to take your text document, right? This is our language. This is our language, right? It goes through our program, which is the compiler. And I know this is terrible handwriting, but essentially it goes through the compiler and outputs IR, right? And this IR can then be put into different things. For instance, you could have one for Windows, a Windows application. That's not how you spell Windows. A Windows application. One of them could be for the web, right? You could be running some sort of web server. Another one could be for Linux, right? And like a normal compiler wouldn't be able to do all of that. This creates an IR, which then gets translated to assembly code in these different languages or in these different systems. This is LLVM. This is what we're going to be using to create that IR. And on top of that, you can have another language, right? Let's say we have this other language here. Let's say this is like C++, right? This can go through its own compiler and essentially output another IR factor, which can then go into other things. So it allows you to also connect with other programming languages, which is what I want. This, of course, is not like the only way of doing it, but it's good enough for me. And again, all of this is just so I can learn how compilers work. I can make my own programming language and hopefully inspire you to make your own. I say a lot, don't I? I did not plan any of this out. I'm gonna be completely honest. So this is, you guys are seeing the raw thought process between my thought. Yeah, that makes total sense. Anyways, compilers, like what is in the hood, under the hood of a compiler? I'm having a hard time erasing all of this. It's good enough. Good enough. Okay. So what is under the hood of a compiler? Essentially, it inputs the text, right? It runs through the front end, which tokenizes everything. It turns everything into tokens, excuse me. Turns everything into tokens. This token then runs through a parser, which is the middle end, right? This parser then creates a abstract syntax tree, or AST for short, right? Essentially like your program in an intermediate, like just byte code. It's little, for if you don't know how computers work, bytes are just the smallest number that you can have inside of memory, right? Anything smaller than that and you're dealing with bits, and it's very, very complicated. But essentially, a bit is an on and off switch. A byte is 8 of those. That's the smallest amount of memory you can deal with in a computer. But anyway, this AST basically is your program in that byte code. Again, the computer doesn't understand how to do it, but your program does. And then it can translate to the output, which creates your file, right? And this is your IR. The thing with any project is you need to realize how that's going to work, how your project is going to work. For instance, this is the flow of the project. Projects can sometimes have flows where it like runs through loops and stuff before eventually getting to the output. Ours is just pretty much a straightforward one creates the other, and then you basically build it in reverse. So we're actually going to be starting with the output today. What we're going to be doing in this episode specifically is we're going to be creating the library, right? So this library can be compiled, or it can be installed into any programming language. So if you want to skip straight to like making your programming language, eventually you'll be able to download this library and do it yourself. Like you don't have to do any of the backend stuff. You don't have to do anything. And then, where was I going with this? I don't know where I was going. But essentially, you start with the back end, and then you move forward in your project. That's why they call this the front end and this the back end. You start in the back, move to the front. You're creating it in reverse, so that way you kind of can build off it. Because the AST can't do anything unless it has an output, right? So create the output first, then the AST, then the parser, the tokenizer, and you have yourself a language. One thing that I've already done that you guys should probably do if you're wanting to follow along and build your own language is plan it out. What do you want your language to look like? What does it need to have? What's the kind of control flow it's going to need? The output doesn't necessarily matter too much because, like, as long as you know what output you're using, whether that be the assembly code of something or a virtual machine or whatever, as long as you know what your output is, the rest of it is kind of up to you and how you're going to translate it to the output. With that being said, I think you should just go ahead and get started because that's enough explanation. I don't want to bore you guys. One thing that you want to probably keep in mind with this is I'm doing this purely from a hobbyist perspective. I'm not a professional, right? I'm not a teacher. I'm not anything like that. I am just doing this for fun. So, if we go ahead and we look at our code here, I just created a basic project, right? This is we're using CMake here so we can compile it onto any system using any C++ compiler, right? So any C++ compiler will work for this. I am building my compiler in C++ just because I don't want to have to do it from assembly code because that's going to suck. So we need to first create we're going to create a new folder. And this folder is going to be called LLVM. And it's going to hold all of our LLVM code. And then we're going to have include, which just has the libraries to it, and lib, which has all of the actual source code in it. So include will be stuff that you can include into your project and have it work, like have it be able to connect to the library. You know, the library is the actual code itself. It's in the compiling process, not necessarily in the linker process where it's linking to everything else. Inside of the include, I'm going to go ahead and create a module.h, and we're going to do progma once, so that way nothing can, it can only be included once. That way your compiler doesn't say, oh, this has already existed before. Like, if you accidentally include this multiple times, like, it already knows it's included, doesn't need to give you a warning. I'm going to create a class, we'll call it LLVM underscore module. Everything is going to have LLVM at the beginning of it, right? Anything that uses LLVM will have an LLVM at the beginning of it. Inside of this module, this up here is going to be functions. And to keep things safe, I'm having everything under the private variable. You can never access anything inside of the module unless you use an external function which has access to the stuff inside the module. This just keeps things safe, because if you check something for, you know, if you do some safety checking, like making sure data types are correct and whatever, and then you change it later on, then that can cause some dangerous side effects. So I'm having my functions up here, and we'll use friend functions, which basically will have a different definition down here, but we'll have access to all of the private variables. And you'll see what I mean in a moment. I'm going to include, we'll do, this is C++ libraries, and this is my libraries. And inside of here, we're going to include string. So now we can do standard string, and we'll call this one output string, right? Output string is going to, it's the directory to your output file, right? If you were to open up any sort of, like, you know, any of, maybe if I can move it in here, there we go. Like, it's your output directory. If I were to go to my files here, like, this is how you access my files. So it's just the location of the file you want to create that has your intermediate representation in it. And then we're gonna also include fstring, and this is the file, or not fstring, fstream, and this is the this is file stream. You can input and output stuff. We're going to create an output file stream, so OF stream, and we're going to call this one output file stream. And essentially, this is the output. This is where we're sending all of our code to. We're going to have a function called init. So we're going to have LLV, where it's going to return a LLVM module pointer, LLVM init, or actually we'll do create module, and take in a string output file, right? And we don't want any of the code in here. We want it all in the library itself. So I'm going to add a semicolon at the end that just says this exists, but somewhere else. So you can call it, but we don't know what it's going to do, right? And then we'll add a friend, LLVM module pointer. This will create LLVM underscore create module with std string, right? So yeah, so this essentially is linking to this. So this now has access to all of the private variables. And if I were to go ahead and I'm going to add a new file under library, this is going to be module.cpp. CPP is short for C++. This just means that it's the library and not a header. It doesn't include external things. It has all of the stuff located in here. We can go ahead and include // include / module.h. So we're going to include module.h, and we can go ahead and do we don't need to do progma once, but we'll do C++ libs and my libs down here, and then we'll go ahead and include this. Doing this will allow me to define what happens when we call this function. You see everything clears up because now it knows that this has some sort of definition to it. So we're going to do LLVM underscore module pointer, call this a temporary module, equal to new LLVM underscore module. So this creates a module on the heap. You will have to use you will have to use delete to get rid of this. You will have to do delete temp module, right? You will have to delete whatever this returns later on when you're done with it, but that's... Hi! Hello, everybody! There's actually people here. Oh my goodness. Welcome to the stream. Turn up my mic. Turn up my mic. This is about as loud as it can go. Does that work? This is my first time streaming after a long time. Showcase to the Passion Project. Showcase to the Passion Project. This is actually the start of the Passion Project. I'm not showcasing anything. You guys get to watch it be created in real time. I'm explaining the kind of how this all is going to work. I am very much aware this is not professional. You guys, like, I'm not trying to keep this professional. I just want to show off the kind of things that I'm doing and show the live, like, how things are created in the real world and not just on YouTube. You know, I want people to see the true, you know, process behind creating things. Anyways, we can now do LLVM or temp module, and we'll set the output string to std colon. Or actually, hold on, we don't need the string because we're only going to be opening this once, and if it doesn't open, then we can return false. So we get rid of that, and we'll do temp module dot output file stream dot open, and we'll open our output file. I can spell output file, and then if temp module, if the output file stream failed, right? If it failed to open, then we can return null pointer because it failed to open something. However, if it did not fail to open something, then we can return temp module. And now, okay, so now we can create our module. We should probably have something to write to the file, but as of right now, I just want to see if it creates the folder, because if it doesn't, then whatever. So now we'll come back to here. I want to, okay, so we'll come up here and we'll go add library, and we'll call this one LLVM underscore output module, and we'll add dot slash LLVM. Actually, let's move this into here, and then we'll do LLVM or LLVM forward slash lib, what do they call it? What do they call it? Yeah, lib forward slash module.cpp, and then we can go ahead and target link libraries. We'll have our project, and we'll target LLVM output module. Theoretically, this Doggo helping with the code. If Doggo wants to help with the code, I won't say no to it. This is like my third time doing this project just because I've had to restart so many times, so I definitely won't say no to it. I'll do include LLVM, include module.h, and we can remove this because we know it works. We know that we're having an output. So let's do LLVM underscore create module being test.ll. I'm going to return an LLVM module, call it module equal to, and this is going to be a pointer. Okay, so theoretically this should create everything. Okay, so we've got no output, which is to be expected. And if we go to output, we'll go to Open File Explorer, build. We can delete this one because we're not using x64 on this device. And it should be under this. Sweet. Okay, so we have our output library. That's working just fine. And we have our test.ll. So created the file. Now, why don't we go ahead and we write something to the file, right? If we want to write something to it. Excuse me. Oh, also, the reason I'm doing this and creating the module that way, instead of creating the module and then accessing programs inside of it, is because I don't want people to access anything inside of this. You can't access output file stream, right? You can't access that. I want it to be hidden. I don't want people to mess around with the code afterwards. We can go ahead and probably create a all right, what do I want to add to this now? I would suggest adding because I've been streaming for half hour. I don't want to add too much to this the first time because I still have to do some research, but I go ahead and probably do a generate function. So inside of here, we'll do void generate, right? This will generate everything. And inside of here, we'll do LLVM, or actually we'll do void generate, or LLVM underscore generate module, and we'll have a LLVM underscore module pointer module, like so. Inside of here, we'll go and create LLVM underscore void LLVM create generate module, and it'll be LLVM underscore module pointer module. I want to double check that that is the same here. In the off chance I probably misspelled it because I'm dyslexic. That's why I like Visual Studio so much, is to prevent security issues, exactly. Because the moment you start messing around with the data after already checked all of it, then is the moment that everything breaks. Anyway, so now we created a LLVM module. I'm gonna go ahead and, or I guess, yeah, so what I'm gonna go ahead and do is I'm gonna go ahead and we'll call, first we'll double check if module is equal to null pointer, then return, right? Because we don't want to run anything if we can't run anything, right? Else we're going to module dot oh, I need to make this a friend function first. Hold on. So we're gonna go back up here. We'll do a friend LLVM module, or no, it's gonna be a void LLVM generate module, and we'll do LLVM module pointer module. Actually, we don't need this. Just know it's a module pointer. I don't think we actually need anything here either. Yeah, but I'm going to keep it there just because I want people to know what they need to, like what it's meant to be for. There. Now if I go through here, I can do module dot, there we go. Now I can generate. And inside of the generate function, we'll come back up here. Do LLVM underscore module pointer generate. This is going to return void, and we'll define it in here. So we'll do output stream, and we're just gonna output something. Hello LLVM, right? Something like that. Slash n, I don't know. I'm just outputting to see if the output works. Now inside of here, inside of our program, we can do LLVM underscore generate module, and we'll pass in our module, right? And then we want to go ahead, we want to free, or not free, delete module, right? I'm gonna delete it all. This will ensure safe checking. I could also, like, if I really wanted to, I could probably do, we'll do, actually include smart, or Frick, which one's the one that's that includes smart pointer? I have to look that up real quick. One. Unique pointer C++. Memory. It's inside of memory. And I could probably do std smart or is it? Am I not able to turn this into a smart pointer? Is it shared? It's shared, okay. Or of type LLVM underscore module. Right. Let's do std make shared type LLVM module. So is this full dot get possibly? This might work. Nah. All right, it's gonna be. Oh, don't look this up, man. Don't look this up, man. Ugh. I hate when it does that. Okay, you know what? It's probably just better to do LVM underscore module pointer. And then we'll just return a module pointer like that. And do that, and then we'll do delete module. Which removes it from memory. Obviously we don't have to do that, but it just kind of like shows it off, keeping it safe. We could start working on like global variables, but I'm not exactly sure how I want to do that. Let's see. Anyways, let's just run this code and see if it works. And inside of test.ll, hello LLVM, sweet. Let's see. We're probably gonna wanna how do we want to do this? Let's create another include. We'll call this one we'll call this one call this one global variable. I'll call it value.h. I think the way I'm going to do this is, and I don't want to actually include this in any of these. We'll do pragma once, and we'll do class LLVM value, and we'll have a private. And inside of here, we'll have actually protected, so anything that derives from this can use it. And then I'm gonna include. We're gonna include here. So we'll have an unsigned char. This will be our data type, right? And this is gonna be like each data type is going to have an ID. That's what this is going to do. And then we'll do and I'm thinking probably gonna wanna shoulda wanna because then we can go into our module and include vector, right? And we're also going to want to include value.h. So then we can create a std vector of value LLVM underscore value objects pointers. We'll call this we'll do, this is going to be global variables, right? We'll have a class LLVM global variable. We'll derive from a public LLVM underscore value object, and it will have a include string, it will be a name or a std string name. It also have, and I'm going to put this under private string name. Also have std or int data extra data. Essentially, variables can have, like, if it's private, public, whatever. It can also have, like, if it's constant or not. I think that's all I need for this. For now, at least. Yeah. It already has the data type, right? So we're going to create another, we'll add a new file and we'll call this one definitions.h. And I'm not going to include it into any of these. Do pragma once, and we'll do, this will be something like that. It's probably too long actually. Something like that. Control C, space, we'll do data types, Control B. There we go. So we'll do hashtag define LLVM underscore none. This will be equal to 0. Hashtag define LLVM underscore void 1. LLVM or define underscore define LLVM underscore I1, which is going to be equal to 2. Define LLVM underscore. Like, I could most definitely be using a enum for this, but the problem with enums is that you can only define things certain ways, and I think it's just much easier to just use definitions, and then if people want to break it, they can break it. I'll do I or I8, which is 3. I'm actually just gonna copy all of this. This will be I16, 4, 5, 6, and 7, I32, I64, 64, float, and define LLVM underscore double will be 8. Then these might also be pointers, and while we could have a copy of all of these for the pointers, maybe it's much easier to do like define LLVM underscore pointer, right? And let's set this to 16, right? And then we can just so we'll do like LLVM underscore I32, and then we want it to be a pointer, so we'll just LLVM underscore pointer, and that will get us the one of the bits. 16 is a bit, it's an on and off switch. That'll turn that on. This just should be a little easier, that we can kind of combine it into one. Then we can do define LLVM underscore pointer, which will be 32. And I think that's that. Let's do actually we'll do global variable LLVM underscore global variable pointers, specifically global variable pointer, because we know it's only be global variables, make it a little easier to get. We do LLVM underscore, or actually we will eventually return a let's LLVM module. So when it's being deleted, I want to go ahead and delete all of our vector stuff. We'll do LLVM underscore module, LLVM module. For size type, index is equal to 0. Index is less than Oh, hold on. Oh, yeah, index less than global variables dot size index plus plus, and we'll do index. We'll do global variable index at index. I'll go ahead and delete. There we go. And I also want to std cout. No, cout. Forgot to include IO stream. Test. And I want to do this for everything. I just want to see if this runs first. What are we? Protected. Here. Ugh, fine. There. There, okay, so it does work because it is getting deleted. There we go. That should delete all of this. Should be no memory leaks now. Let's just go ahead and do. I'm not gonna fully create anything. It's not gonna generate or whatever. We can do friend void LLVM underscore create global variable. We'll do LLVM underscore module pointer. We can get access to it down here. LLVM underscore create global, nope, create global variable. LLVM module pointer capital M module. It's not going to return anything as of right now. Soon it will return an ID pointer, but for now, this is all it's going to return. I apologize about my dog in the background. And inside of here, we'll go ahead and we'll that. And we'll just be module like that. Module. And inside of here, we'll do, again, check if that is equal to that. If not, we will go ahead and do LLVM underscore global variable pointer temp variable equal to new variable. No, new global variable. And we'll do temp. We'll do temp variable dot. I need to make a friend function. So we'll do up here. We'll do that, and then also we want to do class underscore module does exist somewhere. We don't know where it exists, but it exists somewhere. Now if I come back to here, I should be able to do dot data type. We also need to include a data type. So over here we'll do unsigned char data type, right? Add an unsigned chart here and an unsigned char to value.h unsigned char. We'll go ahead and here unsigned char data type equal to data type and that should we'll do module dot that module dot are we oh I see do that there we go. Now it should be dot global variables dot push back temp variable. And just to make sure things are working, we'll do public or we'll do LLVM underscore global variable. Actually, should be fine. Should be fine. We're not. Should be fine. If we run this, nothing should happen, obviously. But I just want to make sure that everything's working, and then we can do LLVM underscore create global variable module and underscore. I forgot to add the definitions one. Inside a module, I want to include definitions, just because I want it to be easy to find later. We'll do LLVM underscore I32 LLVM underscore pointer. Doing that will make it a pointer as well. And this shouldn't corrupt anything, I don't think. Sweet. I think that's as far as we're going to get. I think in the next episode we will actually create a proper global variable, but this has a bunch of extra things that needs to get done to it. I just wanted to show that we could create stuff and do all of this and keep everything safe. And yeah, I think with that, I'm probably going to go ahead and end the stream. I hope you guys enjoyed. I'm sorry it was very boring, but at least you get to see like the real thought process and the real way that all of this is created behind the hood in actual development. You know, it's not as fun as, or not as fun, it's not as intriguing. No, that's not even a word. It's a lot more all over the place than tutorials make it seem. So hope you all enjoyed, and I will hopefully see you in the next one. I don't know if I'll stream it or if I will make a video, but we will see. Hope you all enjoyed, and I'll see you guys in the next one.